power is the rate of change of energy from one form to another form. You'll see this in work energy power in mechanics. So power is energy over time. So power is in watts, energy is in joules, and time is in seconds. So you must make sure when you do the calculation, the units must be correct. So there is this definition that you may possibly be asked to write down. 1 watt is 1 joule of energy that is converted to other forms in 1 second. Then prefixes, 1 kilowatt is 1000, 1 megawatt is a million watts. You do that in math also, right?
Yeah.
So this line, for electricity, power is current times potential difference, or current times voltage, or current times potential difference, or EMF. So power is in watts again, P will be in volts, and then current is amperes. If you have any prefixes, you need to change all of them. So there are more versions of the formula for power. There's this one and also this one. So you need all forms of the formula for power, because when calculation takes place, right, you would check which variable is given, then you will use the formulas accordingly. Then the parallel set energy, because energy is power times time, so you will have 3 other forms for the formula for energy. Time is in seconds. Okay, yeah, you probably have to write it down somewhere, or you have your textbook and you just refer to your textbook. I'm sure they are in the textbook. So SI unit for energy is joules. 1 kilojoule is 1000 joules. 1 megajoules is a million joules. Same thing as power. There we go. So what I do with questions like this is I'll just read and write down what is given. A current of 2.5 amperes is flows through a resistor. A source of EMF 6 volts is provided in the circuit. Then they say determine the power. That's A. So I would, because now they're asking for power, right? So I will go to my mind and then I find all the formulas. Then I'll just use the formula that has P, I, and V. So then the second part again, so this is given. So I is 2.5, okay, V is 6, then time is 10 minutes, then we are supposed to find energy. So then I will go to my list of formulas again and then look for a suitable one. So just now we have this one. So what should we do next?
Or since calculate the power already, you can use the power times time.
Yes. So then its energy is power times time.
Then must convert the 10 minutes into seconds.
Yes, that's right. So becomes 60 seconds. Is it? Is it?
Yeah.
Ah,
10 minutes is 10
is it
times
60 seconds?
10 times 60.
So it should be 600 seconds. So just now, power was what again? 15. 15 times time. This is the power rating. So that means the bulb has a power of 100 watts. Then this is the amount of voltage that goes in. Then here, right, the heating element, the power is 3 kilowatts. Means it's 3000 watts. So then they say talk about bulb only. So you will use this data only. V is this, P is this. Then they say find current. Okay. Then same thing. So now you only look at this. P equals IV. So I equals to P over V. Okay, formula correct. So power is 3000 divided by 250. So now they ask, which of the electrical components dissipate more heat in 5 minutes? It's quite obvious. If it's an MCQ question, you could just use your calculator and then just get the figure, or you don't even need to use the calculator. It's quite obvious, so you can choose the answer. But because now this is a structured question, then you would have to provide working. So you are likely required to find out how much energy the light bulb use and how much energy the heater use. So how? Need help? So which of the electrical component dissipate more? What is this? This is the bulb. So we can put the bulb. So energy is power times time. So it's 100 times 5 times Energy comes in units. Then you have the heating element. 3000 times, okay, so you get, so then from here you can say that it is heating element. So I think now you can handle this on your own. Current is power over this.